Okay, so we're starting Unit 3, all about quadratic functions. We're going to kick off by graphing quadratic functions. Now, quadratic functions, you studied a little bit in Algebra 1. You should remember that that is a parabola. And what we're going to be looking at throughout this unit is actually very important in the real world. You can see some of the images I have here. We have a satellite dish. The shape of a satellite dish is a parabola. It's a very important quadratic function that we use whenever we talk on the phone, whenever we use the internet. That all involves satellites. You can see here the Golden Gate Bridge. Those cables are in the form of a parabola. Parabolas are very important for engineering purposes to hold things up. And then, of course, you have a basketball headed into the basket there. That's a parabola. That's gravity. Everything around us involves quadratic functions due to gravity. So these are just a few of the things that we're going to highlight throughout this unit. All right, so what is a quadratic function? Quadratic function is a second-degree polynomial, meaning that the highest exponent is a 2. That's what second-degree polynomial means. It means your highest exponent in your equation is a 2. So basically, every equation we're going to be working with in this unit is all about x squared. And for some people, this is a little counterintuitive because we know that quadratic, quad, indicates 4 of something. Like if you think of quadruplets, that means that there are 4 kids. So when we think quad, here we're only dealing with x squared. So one way to think of this is the most basic quadrilateral that you can have is a square. And so quadratic function is just x squared. So quadratics are used with area models like square footage. That's quadratic. All right, there are 3 ways you can write the equation of a quadratic function. The first is standard form, which looks like this. Y equals ax squared plus bx plus c. For example, you might have something like y equals 3x squared minus 2x plus 7. This is a quadratic equation because it has that x squared. The next way you can write a quadratic function is in vertex form. Y equals a times x minus h squared plus k. This is the one where we're going to be focusing today. An example of this would be y equals 1/2 x minus 3 squared plus 1. And last, you could write a quadratic equation in factored form. Y equals a x minus p times x plus q. Using actual numbers here, that might be something like y equals -4 times x minus 1 times x plus 5. Now, each of these 3 forms represents a quadratic function. The first one obviously already has the x squared in it, but the second one, when you square this, you'll end up with an x squared in your equation. And same thing with the factored form. If you were to go through and multiply this out, you would end up with an x squared. So all 3 forms of a quadratic function involve that same basic x squared. Okay, now when we think about graphing, we're going to have to start graphing the parent function. Remember, the parent function is just the most basic function you can have of a family. So for quadratics, it's all about the x squared. So the parent function is just plain old y equals x squared. All right, so let's take a look at what this is going to look like on a graph. Let's start with 0. If you were to plug 0 into this equation, 0 squared is 0. The plot here is at 0. 0, 0. Next, let's plug in the number 1. 1 squared, 1 times 1 is 1. So I'm going to go over 1, up 1. It's my second point. Next, let's plug in a 2. 2 squared, 2 times 2 is 4. So I'm going to go over 2, up 4. That's my third point. Now let's try 3. 3 squared, 3 times 3 is 9. So I'm going to go over 3, up 9. Now I'm running out of room here on the right side, so let's work on the left side. Let's plug in a -1. -1 squared, -1 times -1 is +1. So I've got the point -1, 1. If I plug in a -2, -2 squared, -2 times -2 is +4. Next, if I plug in a -3, -3 squared, -3 times -3 is +9. And here we get this nice U-shaped graph that we call a parabola. This is the quadratic parent function, y equals x squared. It follows an important pattern from the vertex, which is what we call this turning point down here in the very middle of our parabola. From the vertex, you go over 1, up 1, because 1 squared is 1. And then you go over 2, up 4, because 2 squared is 4. Then you go over 3, up 9, because 3 squared is 9. If we had a much larger graph, we would go over 4, up 16, because 4 squared is 16. All right, so what we want to understand about the parent function is that it starts, the vertex, at the origin, and it follows this pattern: over 1, up 1, over 2, up 4, over 3, up 9, and so on and so forth, because it's all about the x squared. All right, so today we're going to focus on vertex form. This is very similar to what we've done in the last couple of weeks with absolute value functions. Just this time we're going to be having that little squared in our equation that makes it quadratic. So vertex form is y equals a times x minus h squared plus k. And just like we saw with absolute value functions, that h value is going to shift your function left and right. A positive is going to make it shift to the left, and a negative is going to make it shift to the right. At the end of your equation, the k value, just like with absolute value functions, that's going to shift your graph up and down. Positive will move your entire parabola up, and a negative will move your entire parabola down. All right, what's a little different here is that a value. That's your dilation factor. That's what's going to stretch or compress the graph, make it wider or make it narrower. All right, let's put this into practice. First, y equals x minus 3 squared plus 1. The x minus 3 here is going to shift our graph to the right 3. And the plus 1 at the end of the equation is going to shift your graph up 1. That's where we're going to start. That's our vertex. So from the center of our graph, from the origin, we're going to go to the right 1, 2, 3, and up 1. That right there is our vertex. Now, we don't have a dilation factor. There's no number out in the very front. So that means we're going to follow the same original pattern from our parent function. So remember the pattern: over 1, up 1, because 1 squared is 1. Over 2, up 4, because 2 squared is 4. And over 3, up 9, because 3 squared is 9. So I'm going to start with this vertex. And I'm going to go over 1, up 1. That's my second point. Now back to the vertex, I'm going to go over 2, up 4. That's my next point. Now back to the vertex. Now I'm going to go over 3, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Puts me just up above the graph. All right, we're going to do the same thing on the left side because it should make a mirror image with this parabola. So from your vertex, we're going to go over 1, up 1, back to the vertex, back to the vertex. We're going to go over 2, and then up 1, 2, 3, 4. Back to the vertex. We're going to go over 3, 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our parabola. Okay, so it's all about that pattern, the same pattern that we saw with the parent function. Over 1, up 1, over 2, up 4, and over 3, up 9. Because each time you're squaring your x value. Try another one. Y equals x plus 4 squared minus 6. All right, x plus 4 shifts our graph to the left 4. The minus 6 shifts our graph down 6. That's where we need to start. That's our vertex. So from the origin, I'm going to go to the left 4, 1, 2, 3, 4, and down 6, 1, 2, 3, 4, 5, 6. That's where I'm starting. Now, there's no value out in the very front, so we're following the same basic pattern as the parent function. So from the vertex, I'm going to go over 1 and up 1. Back to the vertex, I'm going to go over 2 and then up 4. 1, 2, 3, 4. Back to the vertex, over 3. 1, 2, 3. Up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, same thing on the left. Go back to your vertex, make a mirror image. Over 1, up 1, because 1 squared is 1. Back to your vertex. We're going to go over 2, and then up 4. 1, 2, 3, 4, because 2 squared is 4. Back to your vertex. We're going to go over 3. 1, 2, 3. And then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, because 3 squared is 9. All right, there's your parabola. At this point, you should pause the video. I want you to try this one on your own. Whenever you're ready to check your answer, press play, and I will work through the problem and you can compare your work to mine. Okay, hopefully you've tried this one on your own. Let's check your work. So x minus 1 shifts your graph to the right 1. The minus 4 shifts your graph down 4. That's going to be our vertex. So from the origin, I'm going to go to the right 1 and down 4. 1, 2, 3, 4. That's where I start. That's the vertex. Now, since there's no value out in the very front, we're going to keep the same pattern as the parent function. So from the vertex, we're going to go over 1, up 1. Back to the vertex, we're going to go over 2, up 1, 2, 3, 4. Back to the vertex, going to go over 3, 1, 2, 3. Up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, because 3 squared is 9. Same thing on the left-hand side. We're going to go over 1, up 1, because 1 squared is 1. Back to your vertex. Over 2, up 4. 1, 2, 3, 4, because 2 squared is 4. back to your vertex, over 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put our point. Okay. All right, let's start adding to this a little bit. All right, here, the only thing different we see in this example is we've got a negative out front. Okay, so we're still going to begin by plotting the vertex first, and then we'll worry about that negative out in the front after that. So the x minus 2 is going to shift our graph to the right 2, and the plus 5 is going to shift our graph up 5. That's our vertex. So right 2, up 5. That's where we're going to start our function. Now the difference here is that negative sign out in the very front. Basically, we're going to have the exact same pattern, over 1, up 1, over 2, up 4, over 3, up 9, but because it's a negative, we're going to be going downward. So I'm going to go from my vertex, over 1, down 1, back to the vertex, over 2, down 4, back to the vertex, over 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, same thing on the left, back to the vertex, over 1, down 1, back to the vertex, over 2, down 4, 1, 2, 3, 4, back to the vertex, over 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so it's the exact same pattern, but that negative just flips it so that your parabola points downward. All right, go ahead and pause the video right now. I want you to attempt this one on your own. Whenever you have finished, press play, and I will explain this problem and you may check your answer. Okay, hopefully you've worked through this one by now. We're going to start by putting our vertex on the graph. So if we look inside the parentheses here, we have x plus 3. That's going to shift our vertex to the left 3. And the plus 4 on the outside is going to shift our vertex up 4. So left 3, up 4. That's where we're going to start our function. Now the negative out in the very front just tells me that instead of going over 1, up 1, we're going to go over 1, down 1. And instead of going over 2, up 4, we're going to go over 2, down 4. So we're following the same pattern as the parent function, just it's going to be pointing downward this time. So from your vertex, over 1, down 1, back to the vertex, over 2, down 4, and back to your vertex, over 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Mirror image on the left-hand side. Back to your vertex, over 1, down 1, back to your vertex, over 2, down 4, back to your vertex, over 3, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, here's where things start getting a little bit more complicated. All right, let's start how we have on the rest of these problems. We need to plot the vertex first. So look at x. We don't have any parentheses here. We don't have like an x plus 3 or an x minus 3. It's just x. So we're not going to shift our graph side to side. We're only going to move the vertex down 5. So not going side to side, just going down 5. That's where we're going to start our vertex. Now what's unusual about this one is that 2 out in the very front. Here my graph is going to be stretched by a factor of 2. So if you remember that same pattern from the parent function, over 1, up 1, over 2, up 4, over 3, up 9. Basically, we're just going to double that. So instead of going over 1, up 1, I'm going to go over 1, up 2. And then instead of going over 2, up 4, I'm going to double it. I'm going to go over 2, up 8. So from my vertex, I'm going to go over 2, up 1, 2, 3, 4, 5, 6, 7, 8. I don't think we have room here, but for the third point on that side, typically you would go over 3, up 9. If you double that, it would be over 3, up 18, which I don't have room for on this graph. So we're going to go ahead and do the left-hand side. So back to the vertex. Instead of going over 1, up 1, I double this. I'm going to go over 1, up 2. Back to the vertex. Instead of going over 2, up 4, I'm going to go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So here my graph is narrower than the other ones we've been graphing because we have stretched it out vertically. That's what that 2 does, is it doubles the original pattern. Okay, I want you to try this one. Y equals 3x squared minus 9. Go ahead and pause the video. Try this one on your own, and when you're ready to check your answer, press play. All right, just like the previous example, here your graph is just going to shift down 9. So we're going to put our vertex down here on the y-axis at -9. All right, and we have this 3 out in the front. That's just going to triple the original pattern. So remember, the original pattern is over 1, up 1, over 2, up 4, and over 3, up 9. Here we need to triple that pattern. So we're going to go over 1, up 3, and then instead of going over 2, up 4, we're going to triple it. So this is going to be over 2, up 12. So over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you're just tripling the original pattern. Same thing on the left side. Normally you would go over 1, up 1. If you triple that, it'll be over 1, up 3. Right? Then normally you would go over 2, up 4. But if you triple that, it's going to be over 2, up 12. So we get a really skinny graph here because it is super duper stretched out. All right, almost there. Now getting into some fractions. We've got y equals 1/2 x squared. Notice there's no plus or minus. You could think of this as y equals 1/2 x plus 0 squared plus 0. So we're not moving our vertex anywhere, we're just starting at the origin. The only thing we're going to have to worry about is that 1/2 out in the very front. So essentially what we're going to do here is take that original pattern, the shape of the parent function, and we're going to cut everything in half. So instead of going over 1, up 1, we're going to cut it in half. We're just going to go over 1, up half. Okay? After that, typically you would go over 2, up 4. If you cut that in half, we're just going to go over 2, up 2. All right, after that, typically you would go over 3, up 9. Half of 9 is 4.5. So here we're going to go over 3, up 4.5. All right, we can keep going here. Next, if you went over 4, 4 squared is 16. So on the parent function, you would go over 4, up 16. Here we're cutting this in half, so you're just going to go over 4, up 8. Same thing on the left-hand side. Typically, you would go over 1, up 1, but half of that would be over 1, up 1/2. Then, typically, you would go over 2, up 4, but we're only going to do half of that, so we're going to go over 2, up 2. From there, you would usually go over 3, up 9. But if you only go halfway, we're going to go over 3, up 4.5. And last, for the parent function, you would go over 4, up 16. But if you only go halfway, that'll be over 4, up 8. And there's your parabola. This one looks a little bit wider than the original functions because you're only going up half as fast. All right, y equals 1/3 x squared. I want you to try this one on your own. Go ahead and press pause on the video. I want you to attempt this one on your own paper. When you're ready to check your answer, press play. Okay, so just like before, we have 1/3 x squared. You can think of this as 1/3 x plus 0 squared plus 0, because there's nothing with x and there's nothing on the outside. So essentially, we're just going to start the vertex at the origin. All right, the only thing we have to be worried about here is this 1/3. So all we're going to do is take that original pattern, over 1, up 1, over 2, up 4, over 3, up 9, and we're going to divide by 3. We need to do 1/3 of the original. All right, this one's a little bit trickier because we're dealing with fractions. So what I'm going to do is I'm going to hold out for the nice, pretty whole numbers. All right, so think about the parent function. Traditionally, you would go over 1, up 1. If you divide by 3, that would be over 1, up 1/3. Not even going to bother putting that on the graph because it's hard to estimate 1/3 on the graph. All right, so let's think about the next point. Typically, you would go over 2, up 4. If you divide that by 3, we still don't have a whole number. So let's keep going. After that, we would usually go over 3, up 9. If you divide by 3, you get 3. So this is just going to be over 3, up 3. All right, now that's only 2 points. Let's keep going, see if we can find another good one. Over 4, usually you would go over 4, up 16. If you divide by 3, that's not a whole number. So let's try again. Over 5, 5 squared is 25. If you divide by 3 there, that's still not a whole number. So let's keep going one more time. 6, 6 squared is 36. So on the parent function, you would go over 6, up 36. If you divide by 3, you get 12. So we could go over 6, up 12. That's off the graph. Forget this. Let's just do the mirror image on the left-hand side. And draw our parabola. That's all it's going to fit on this graph. All right, let's try putting it all together here. Y equals negative 1/4 x plus 2 squared plus 7. Attempt this one on your own. Press pause. Whenever you're ready to check your answer, press play. Okay, so here we're having to put everything together. X plus 2 is going to shift our graph to the left 2, and the plus 7 is going to shift our graph to the right 7. So left 2, up 7. That's going to be our vertex. That's our starting point. Now we can work with this stuff out front. We've got negative 1/4. So what we want to do here is take the original pattern, over 1, up 1, over 2, up 4, over 3, up 9, and we essentially want to divide by 4 and make it point down because we have a negative here. All right, so let's think about this. Over 1, up 1. If I divide by 4, I get a decimal. Let's skip that one and go to the next one. All right, after that, we would go over 2, up 4. If you divide by 4, you would get over 2, up 1. We have a negative though, so I'm going to go over 2, down 1. From there, over 3, up 9. If you divide by 4, you get a decimal, so we'll skip that one. And let's go over 4. Typically, you would go over 4, up 16. 16 divided by 4 is 4. So we're going to go over 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4, because it's negative. All right, let's go one more. Let's see. 5 squared is 25. That's not divisible by 4. 6 squared is 36. So we would need to go over 6 up 36 on the original function. If I divide by 4, you get 9. So we're going to go over 6, down 9. So from the origin, or from the vertex, we're going to go over 1, 2, 3, 4, 5, 6, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing on the left side. I'm just going to make a mirror image. Over 2, down 1. Over 4, 1, 2, 3, 4. Down 4, 1, 2, 3, 4. And then over 6, 1, 2, 3, 4, 5, 6. Down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have reached the end of today's lesson.